Hello and welcome to this video. It's a pleasure for me to see you here again and what we are talking about today. I'm talking today about an open source project that's started by JFrog and now part of the Linux Foundation, and it's focusing on supply chain security inside the open source world. So this is a big topic, supply chain security, and how we can help there, and what is the mechanics of this decentralized distributed package management system. Then you are exactly right here now. By the way, my name is Sven. I'm in the region of Brunswick, it's in Germany, and I'm here in this area that's called Harz, and the last snow is lying around here, and spring is coming, the sun is stronger every day, so it's a wonderful time here for a hike, and I will take you with me to this journey. And by the way, if you're the first time on my channel, then big welcome from my side, and if you like this video, give me a thumbs up and don't forget to subscribe my channel so that you will get information every time there is a new video. So, and now we want to start talking about Project Pyrsia. So let's start talk about Project Pyrsia. Pyrsia is an open source project, and it started by JFrog, the company that's building Artifactory in X-Ray, the DevSecOps platform. And now it's part from the Linux Foundation. So it's really an open source project. It's not owned by JFrog, it's part of the Linux Foundation now. And what we want to address. So inside the open source world, we have different dependencies. So let's talk about Maven. I have my Maven, then I'm declaring dependencies, and these dependencies will have different dependencies, and so on and so on. And where I'm getting these binaries, mostly I'm going to a central place, and I have to trust this central place that this is not compromised. And the other thing is I have different dependencies, and between these dependencies I want to make sure that there is no compromised binaries in my dependency chain over the whole chain of my project. So what we are building with Project Pyrsia, it's a decentralized package network, and it aims it tried to find a solution for this supply chain security, so that you have different certified nodes that are trusting each other but verifying each other. And this decentralized network is working in a way that if parts are going down, other parts can support the rest of the network in some kind of self-healing structure. I will explain a little bit more about the structure itself in a few minutes, but think about a decentralized network that's understanding the metadata of dependencies and packages inside the software development, so that you can define, I want to have the package with this version number, and then it's understanding, okay, where it is, how to get it, how to verify, how to make sure that this is a valid thing. So, and there are a few parts in this architecture I will cover in a few minutes, but the main idea is to build a decentralized package network with Pyrsia. Okay, what the main thing we want to address with Pyrsia? With Pyrsia, we want to secure this part of the supply chain where you are creating binaries and storing it. So assume you are the maintainer of a project and you're building this binary on your machine, inside your CI environment, whatever. You have to make sure that this binary is not compromised, your own machine or your CI environment. A big example of compromised CI environments is a SolarWinds hack, and there it happened exactly this. So the CI environment was compromised, and with every build you had compromised binaries. So make sure that the CI environment is secure. It's the first thing. Then you have this binary and you want to share it somewhere for the open source world. So you're pushing it maybe to Maven Central, you're pushing it to Docker Hub, and then you have to trust that this authority, the single place where all this stuff is stored, is secure as well, so that the binary is not compromised. And if you have mirrors of this one, that these mirrors are not compromised as well. So you see that over the whole chain we have central places, we have mirrors of all this, and we have to secure all of them, or we have just trust them. And this is some kind of critical, because attacks against these authorities are bigger and bigger. And if you have a single place, if this is shutting down for whatever reason, denial of service attack, or it's just tagged, or power outage, or whatever, then this single place is away, and who's doing the job then? Okay, so the main thing is, or how it works. If you have an open source project, the source is free available, it's there. And then different nodes, if you're pushing it to the network, different nodes can grab this software and can build the binary. And then they start syncing between and make sure that this binary is not compromised. And if you have this binary already in some central place or in some different places, then if one node is just away, the other nodes can deliver this one. It's a peer-to-peer network. So altogether means you have distributed builds. They are verifying, building this network of trust, and then these binaries are shared in different or between different nodes. And this trusted network is making sure that an outage in some parts is more or less compensated by the rest of the network. I want to explain a little bit the defined goals of this project Pyrsia. So I copied the original definition from the project, and there we discussed the following. So focusing on building and distributing open source code bases means that if I'm able to build on different nodes with the source code, it must be the same source code on all nodes, otherwise I'm creating different binaries. So there is this single code source, then this code will be grabbed to this node that are building it, and so I don't have the possibility to change this code in the background. So then easy to install means we want to provide a command line interface, and this command line interface is for installation and communicating with Pyrsia, so that you can integrate with this command line interface Pyrsia into existing environments that are there, so that this connectivity is easy and scripting stuff is easy. You can easily use it in Docker images and so on and so on. Okay, then efficient resource management, or helping to be more efficient in utilization of resources. If I have these binaries already in different nodes and a peer-to-peer structure, then I can provide the functionality if I want to download bigger binaries that I'm getting parts of these binaries from different nodes, and this is just using the bandwidth, the existing resources, way more efficient. So ability to work offline. So a node should be switched to offline mode if you're in an air-gapped network, train, flight, whatever, so that you can work with the existing stuff that's already fetched and cached locally in this node. And then later you can switch on and connect to the network, and then it's syncing back all the stuff that happens. So that's one thing. And then we have inside this production line of building source code some points we definitely addressing. And one thing is, for example, we want to make sure that source code is not modified after it's pushed to the version control system. And if you're building on different nodes, then you can verify easily that it's the same source code if you're creating the same binary. Otherwise, there is something. So this is an addressed topic. Then compromise build platform. With this distributed build platform, we make sure that if there's one build platform compromise, you can identify it easily because producing different binaries. So this federated network of build instance is helping to identify compromise build environments, and then you can exclude them easily. So then using bad dependencies. Using bad dependencies means if you are grabbing dependencies just from the secured network, then this is good. If you are grabbing one dependency from external and the secured network, then it's flagged so that you can identify and make sure and decide if you really want to have this one, yes or no. Then bypassing the CI/CD environment. So what could happen is that you are grabbing the source code inside your company, building it on your machine and pushing this one to the repository instead of the CI/CD environment that should push this binary there. Okay, now there are a few on skis here. Okay, let them ride. Okay, so the main thing is that without bypassing the CI/CD environment, you make sure that you are not building on a dedicated platform some compromise and pushing it to the repo. Okay, then compromise package repo. Make sure that if you don't have a single point where the binaries are stored, you can't modify this one. Or even if you're modifying one of them, the federated network will be able to identify these compromised binaries and to make sure that this is easily addressed and can be removed. And using bad packages means if you are inside this environment and you have the knowledge about there is something wrong with the package, you can flag it, and then you can share this information in the whole network and make sure that you are not using this binary again. So these are the main topics we want to address with the project Pyrsia, and have in mind this is a very young project right now, so we're in the beginning of 2022, so over the time it will be maybe a little bit modified, but these are the initial and main goals of project Pyrsia. The next what I want to explain is what key elements we have in this project, so different nodes and how they are working. Pyrsia is built on with different blocks, and one block is a building block, and the building block is a daemon, and this daemon will get an URL with an hash code, and this is the address of the source code. Then it will fetch the source code from this official repository, and this source code then will be used to build the binary inside a Docker environment. So this daemon will start in Docker environment with build infrastructure, pushing the code in, building the binary, and then this binary will be distributed to this, or will be pushed to the distribution node that will be share all the binaries. So here it's really URL, hash code, grabbing source code, building it in Docker environment, and after this the Docker environment will be thrown away, and you will just hold the binary itself. The second node I want to explain is a distribution node, and this one is more or less a peer-to-peer network where the binaries are stored and delivered. So if you are requesting a binary to one of these nodes, it could happen that you are getting streamed from different nodes of this network, just to make sure that you are using your bandwidth as much as efficient as possible. So that's the advantage of a peer-to-peer network. So this distribution network is just holding the binaries. You created it already, so you have replications already, and then you can grab bigger binaries from different nodes at the same time. So it will be split in different parts, so like a peer-to-peer network is working, and then you will just get this a little bit faster than just from one node. Okay, so you saw what main challenges we are addressing with the project Pyrsia, but there are these existing repositories already, so Docker Hub and Maven Central and all this. And we can integrate these authorities with the concept of a trusted node. So these trusted nodes are integrated, so if you are requesting your Pyrsia node for a Maven dependency, then it can check inside the trusted network as well as this trusted node, then fetching this binary from this trusted node, holding it and delivering it through you. So what we are getting with this we are getting resilience. So if the main node is not available inside the network, we have replications of this. If it is a big one like a Docker image, a huge Docker image, we can serve now from this trusted node as well as different peers from the trusted network, from the Pyrsia network itself, the classical Pyrsia network. So with this we are addressing different topics, and we can integrate existing repositories that are trusted so far, and making sure that we are using existing resources way more efficient than it is so far done right now. So that's an open source project, means go to the website, check out what's the actual state and what's going on here. It's a young project, it's just growing right now, and you can go to GitHub, and like every open source project you can contribute, and it's highly appreciated that you are doing some tests, giving feedback, searching for bugs, committing code, whatever you want. So if you want to know more, just ping me or write to the Pyrsia team, or just write it down in the comments if you have some ideas or some recommendations. So with this, I'm done for this video. So I highlighted the project Pyrsia and the initial state, what's going on right now and why we are doing it. And on the other side, I will now hike a little bit more. The weather is beautiful, and I will use the rest of the day for my hiking trip. And whatever day and time you're using watching this, have a good rest of your day, stay safe, and see you in the next video.